Hello everyone, my name is Akash Chandra Gupta and today in this video we will be deriving Newton's forward interpolation formula. So let's just go ahead. As we can see, the Newton's forward interpolation formula is given by this formula here, which is given as y of naught, initial value of y, plus p del of y naught plus p minus 1 2 factorial del square y naught, and similarly as we know. And here p is the x minus of x naught by h, where x is the point to interpolate, the point where we want to interpolate, and this h is the difference between x, that is the difference between two consecutive values of x. So to prove this formula, we need to consider a nth degree polynomial which is given by this function of fx, which is a of naught plus a1 x minus x naught plus a2 x minus x naught and x minus of x1. Okay, dot 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 up to a of n, and a of n is x minus x naught x minus x1 up to x of n minus 1. What you should notice here is that the base of a is equal to the number of bracket terms. So here when the base is 1, the number of bracket term is 1. When the base is 2, there are 2 bracket terms. Similarly, when the base of a is n, we have n bracket terms, and the bracket terms are also have a pattern in them, which is x minus of x naught up to x minus of x n minus 1. So what we do here is we substitute the values of x consecutively starting from x naught up to x of n. So first value of x is x naught, so substituting it in the function of fx, so we get function of x naught to be a naught only. Why? Because all the terms after a naught contains bracket which contain x naught. So here there is a x naught term, here is also an x naught term. So what happens when you substitute here x of naught, this x naught and x naught get cancelled out, and this whole term turns out to be 0. Therefore all the terms after a naught turns out to be 0. Therefore a naught is equals to y of naught. Y naught, we have substituted replaced f of x naught by y of naught. Okay, because here we have supposed that y is equals to f of x. Function of fx is represented by y, so function of f of x naught is represented by y of naught to maintain the pattern. Okay, now again substituting x is equals to x1, as I have said, we will continue this process up to x of n. So substituting the x is equals to x1 in the function fx, what happens here is that terms which contains x1 in the bracket will get vanished. So here this two term doesn't contain x of 1, but terms starting from a2 up to a of n all contains x of 1 in them. So what happens when we substitute x of 1 here, this whole turns out to be 0, and all other terms turns out to be 0. Therefore the only non-zero terms are a0 and a1. So we substitute here x of 1. You see here x of 1 and x0 are two consecutive values of x, so the difference between them will give us the h, which is the difference in x. And f of x1 is y1, as we know, maintain a pattern. So a of naught is equals to y of naught plus a1 of h, and a1 is equals to y minus y naught by h, and this y1 minus y naught is nothing but finite difference of y by h, and a1 is equals to del y naught by 1 factorial of h. Here 1 factorial I have written because here you can suppose here already 1 is there, so 1 factorial is equals to 1, so we can write 1 as 1 factorial, it doesn't bother us. So similarly substituting x2, we get up to values of x a2 on all the terms after a2, that is a3 a4 a5 dot 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 a of n, all those terms turns to 0. So we substitute here x2 in the place of x, we get this. And further you see here that x2 minus x naught is 2h, because x2 minus x naught, they are they are not consecutive. There are two differences lying between them. The difference between x naught and x1, and difference between x1 and x2. So there are two differences, that is why we have written 2 of h. Similarly here also two differences are lying, so we have written 2 of h. But here you see x2 and x1 are consecutive, so therefore only one difference line between them, and therefore we write h. So simplifying this process and eliminating a2, for a2 we get this. Okay, and what you see here is we have 2 here, we can write 2 as 2 factorial. Alright, no problem with that, because 2 factorial is 2. And a of 2, what you see here, there is something pattern you can see here. Base is 2, there is 2 over del, there is 2 factorial, and there is power of 2 over h. Further proceeding in this similar manner by substituting the values of x to be x3, x4, dot 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 up to of xn, we obtain the values of a's. So we can generalize this whole thing into a generalized expression for n, which is given by a of n is equals to del of n y naught by n factorial h of n. So as I have said, you see here 2, 2, 2, that is why we have substituted a of n and n. You can proceed this, you can see 1 to more values, you can find 1 to more values of a's, and you can see that what we are getting is this general expression only. So we can generalize this in this form. Now as we have given in the, as we were given in the statement that p is equals to x minus of x naught by h. So what we do here is, you see p is equals to x minus of x naught by h, from where we get p x minus x naught is equals to p of h. Similarly, to find all these values of the function, you see here all these terms in the all these bracket terms, you have to find the values for these bracket terms. To do so, we use this expression. Sorry. For similarly x minus of x1, we get x minus of x naught minus of h, because x minus of x naught minus of plus of h, and multiplying this term in the bracket with the negative sign and opening the bracket, we get this term. So we can write this x minus of x naught minus of h, and x minus of x naught is nothing but p of h. So p of h minus of h is p minus 1 of h. Now continuing this process, similarly we obtain x minus of x of n minus 1 to be p minus of n minus 1 whole of h. Now we have found all the values of a, we have found all the values for the bracket terms. Now all we have to do is to substitute these values into the function we have let. So after substituting this function, what we obtain is nothing but our Newton's forward interpolation formula. So I have not done this I have not showed here the substitution explicitly. You can do it on your yourself. It's a quite straightforward procedure. You can just do it on your own. So what we obtain and what you see here is the Newton's forward interpolation formula. This is the required formula, where p is equals to x minus of x naught by h. H is the difference in x. This equation is known as Newton's forward interpolation formula. So thank you guys. I hope you understand it. If you didn't, just go through it once more, and if you want to understand the finite differences operators, you can just refer to one of the tutorial I made earlier. It's based